Hi everyone, and a very warm welcome to today's webinar titled Why Most Businesses Aren't Using Battery Energy Storage Units Properly. Thank you so much for joining us. My name is Brian Holland and I'll be your host today. We're coming to you live from Paralectrics HQ here in Bristol, and we're really pleased to be diving into this topic as it's one that's growing in presence across so many sectors. And given the numbers on this webinar, one that's clearly captured your interest too. Now, as many of you all know, Paralectrics has been a key player in the temporary power space for several decades now, mainly offering conventional diesel generators, with batteries or BES units, as they're often called, being a relative newcomer to the scene. As a fleet operator and an early adopter of this technology, we've been deploying these units into a variety of sectors and applications, ranging from construction, utilities, healthcare, film, TV, defence, and many more. This provides us with a unique perspective into when and where batteries can work well, but also where the challenges can arise. We've learned a great deal, and as a result, we have a very good understanding of how to use them so that they deliver value. The objective of this webinar then, as the title suggests, is to help you to understand whether or not you are using BES units effectively. And if you're not, then how we move you towards achieving that. So we'll be sharing our insights and learnings with you firsthand, hopefully giving you some confidence to make better informed decisions, to optimize your applications and projects, or maybe even start using them if you haven't started using them yet. We'll talk about where the gains are environmentally through reduced emissions and financially through cost savings. There's also an opportunity for you to ask questions during the webinar. So Sam, our marketing manager, can you give us a quick run through on how they can engage with us, Sam, on that one, please?
Yeah, sure. So we will have a Q&A session at the end of the webinar. We're using Teams, the Q&A tool built into Teams. So you'll see at the top of your Teams window this Q&A button. And if you chuck your questions in there, we'll get to those at the end of the session. Any questions that we don't get to, we will be replying to directly.
Okay, thank you, Sam. So let's get going. Today, I am delighted to be joined by two very experienced and widely respected industry experts, Rob Mason of Paralectrics and Dan Pratt of Greener Power, both of whom bring with them a huge amount of industry-based experience. Guys, just before we dive into the first question, would you like to just introduce yourself to our listeners?
Thanks, Brian. Yes, so I'm Rob. I've been here at PE for nearly 13 years now and 25 years in temporary power market, which seems like a very long time. Paralectrics, I've been involved with a lot of projects, including the technical side of battery energy storage systems, the BESS, various work with greener fuels and other technological advances within the business.
And I'm Dan. I've been similar to Rob, working in temporary power for 20 years, so not quite as long. But so I joined Greener to set up the UK business back in 2022. Little bit of background on Greener. It was founded in the Netherlands in 2018, and we now have a fleet of around 200 large-scale battery energy storage systems that are based across the UK and Europe.
Okay, thanks, guys. So let's get going then. First question to Rob. Rob, could you just kick us off by giving us a background on what BESS units are, why they're becoming such an essential component in the temporary power market, please?
Sure. So simple terms, a battery or a BESS, battery energy storage system, and various other names that people use in the industry, basically can be considered as a box of electricity, storing excess energy from various sources. Imagine having a selection of generators or grid supplies or other energy sources like renewables and storing them in a place so you can make use of that generated energy at the times that suit the load. So generators, for instance, running at optimum levels, excess energy from solar and wind stored, all for later use. Phrases such as wet stacking in the industry or low loading can be solved with the use of the batteries as well. So a 300 kVA generator running at 30 kVA, but it's there to deal with the load spikes. Battery is used to cover this. As sustainability becomes the forefront, energy storage and efficient use is becoming more important, both from a cost and emissions point of view.
And how do BES units interact with conventional generators, and what are the benefits?
So, in most setups, the BES is the silent controller. It's running the system, deciding what needs to happen. It does this by looking at the load, deciding what's the most efficient source of energy to use, be it the grid, the generator, renewables, or even just the battery on its own. Or whether they get really clever, is a mixture of all. Benefits from this are the reduced emissions, fuel savings, and silent power. One of the major benefits of running a controlled loads is the sustainable efficiencies that can be gained. The generators and most energy sources have a particular level that would make them efficient. Take the stage 5 conundrum. Efficient running is taken to be around about 70-75%. Unfortunately, a site load or any electrical load is never that standard. Using the battery systems enable us through storage to do peak shaving and basically enable generators and power systems to be run at an efficient load. It's important to note that after several years, BESS and batteries, they're not a new technology. Here at PE alone, we've been working them for about 10 years. But the use in real world scenarios and the use with them in generators is one that is starting to emerge and not happening very well. But it's very important from an energy from sources such as solar, wind, and other renewables are also considered alongside these batteries.
Dan, my next question's for yourself. What are the common misconceptions about BES units?
Thanks, Brian. I think the main misconception is really around BES systems are that they can't handle large peak impact loads. Whereas in actual fact, these kind of transient loads are the ideal applications for battery systems to be used. Using a BES to boost a small grid connection or hybridize a generator are where the best cost and environmental savings can be found. High voltage lithium ion battery systems are still relatively new to the temporary power industry. Power users are getting quite familiar using smaller lead acid battery systems to hybridize smaller generators up to around 60 kVA. These are great for certain applications, but do have limitations due to the inverter size and the battery chemistry being used. High voltage lithium ion battery systems are much better at reacting quickly and can deliver energy, so to discharge or take in energy to charge much faster than the lead acid systems. Greener battery systems have a single 250 kilowatt bidirectional inverter, allowing the battery to discharge or charge at full rate of 250 kilowatts at any time. The inverter can go from 0 to 100%, whether that be negative or positives of charge or discharge, within a matter of milliseconds. The energy storage installed in the majority of our BESS fleet at Greener is 422 kilowatt hours, and generally we use a charge and discharge cycle range of 30 to 90% state of charge. This means that actual usable energy in each system is around 250 kilowatt hours, resulting in the ability to charge from 30 back up to 90% in around an hour, or equally power a load of 250 kilowatts for, again, an hour. Of course, these charge times are all relative to the load. If there is a 250 kilowatt energy source, such as a 350 kVA diesel generator connected to the battery as a charging source, but at the time the average load is around 125 kilowatts, that load would put the battery inverter at 50%. When the generator is started to recharge, although the generator will be running at 250 kilowatts, the battery in this instance will only be charging with the delta of 125 kilowatts, which in this case will result in a full charge within 2 hours.
Right, okay. And what capabilities do batteries have that customers or users wouldn't necessarily always realise?
Well, I think peak power delivery is key. Temporary power solutions for applications where large dynamic loads are present make a very easy business case to utilise a large battery system. These are the sites where usually a large generator would be specified, but ran very inefficiently due to the low load periods where machinery is not being used, or overnight after a shift finishes, or equally if the machinery in use has very high starting currents, but much lower running currents. A couple of examples of this would be thinking of a tower crane or a mobile MRI scanner. These require huge peak power when the crane is lifting or slewing, or the scanner is scanning. However, when these machines are at idle, the power demand is almost zero. In fact, from data we've gathered, a crane will only use between 20 and 100 kilowatt hours of actual energy in a day. To run a large generator, usually between 200 to 500 kVA, to be capable of powering these short peak power demands would be incredibly inefficient. It would also lead to problems for the generator, especially if it's stage 5 due to low loading for extended periods of time. A much cleaner, more efficient solution would be to trickle charge a BES from a smaller grid connection on site and let the batteries invert to power the crane or scanner. Equally, if this small grid connection is not available, then utilising a much smaller generator to recharge the battery system for a few hours a day is far better for the environment, and also adds the benefits of silent running overnight. I think another thing to consider with BES systems is it opens up the opportunity to utilise multiple energy sources, as Rob was saying earlier, such as wind, solar, hydrogen, grid connections, and all diesel generators as well. And all of these energy producing assets can be controlled by Greener's in-house developed energy management software. In all these instances, the battery system becomes the grid forming device.
Sure.
And it's that grid forming device that's quite required to make all of these different energy sources work together. Finally, the other thing is that it's now possible to parallel Greener battery systems, which I don't think's been a thing historically.
Yeah, sure.
So we've run projects utilizing up to 10 of these batteries that are able to deliver 3 megawatts of peak power with 4 megawatt hours of energy storage. And because of this paralleling capability, that also means we can provide backed up or redundant power supplies from our batteries, as you would have done historically with a pair of synchronizing generators.
Rob, over to you. You recently worked on a project with Compleo Health, for which a case study was produced. Could you just walk us through this, highlighting what the requirements were, what equipment was provided, some of the challenges that were faced, and of course, the solution?
Yeah, thanks, Brian. So, yes, as you said, prime example of some of the successful projects we've done is working with medical supply companies for the mobile and relocatable scanners. Done quite a lot of work for these. Now, the temporary power industry has for many years been of the opinion that the way to run these is with a 300 kVA example generator per unit. It's to do with the spikes in the load for the MRI and the CTI scanners in particular. Very problematic for generators to accept sudden impact loads, so you have to go up in the size of the machine to do it. As you can see from some of the images that Sam's putting through now, this particular project had very tight access issues, as well as a lot of local residents and also a hospital recuperation centre very nearby.
This time.
So as Dan said earlier, the major benefit of using batteries is to handle the large spikes. So the 4 units where we had 2 CTI scanners, an MRI and a support unit would have normally resulted in at least 2 300 kVA generators or even a 500 kVA running. But then with the background load of probably only about 25 to 30 kilowatt overnight, this generator still running would have been a huge amount of fuel being consumed, emissions, and also noise. We then skip. So as Dan has said, the major benefit is the spikes on that. The main benefit of this system with the 300 kVA in the battery was that the battery was able to support the load.
Right.
We would take the spikes of the units and they're operating and still give a silent power overnight for the residents. We then ended up with a reduction of about 70% in fuel consumption and 88% reduction in runtime. We've now looked to scale this up still further, working with Compleo as our partner on this system, and move it on further. So we're now using the batteries in their grid shaving mode. There's no generator, no emissions whatsoever. And because of the ability of the battery to constantly charge and discharge instantly, we're able to run this, what would be a 300 to 400 amp supply to the site, off the 100 amp grid supply. We're doing quite a lot of work on this. We plan to release very soon some very interesting data from this site where we're reducing the need for the input current. we'll be doing this in an open source format, so it'll be learning for all. There'll be some very exciting results once we get them out there. And it's going to be a very big change, we feel, for the medical industry on what they can run these scanners from and the power supplies that are actually needed.
Right, okay. 70% fuel savings. Now, that's impressive. Would that have offset the cost of hiring the actual BES unit?
So now you're asking the pointy questions. You've been taking lessons from Laura Koonsberg, have you? The honest answer on this installation was yes, it did, and by a considerable margin.
Right.
But being honest, this is not always the case.
Right.
It does depend on some other parameters or requirements of the site, such as emissions, silent power, load, and if you're on grid, the supply of the grid supply. It's always really important to judge everything against all these measurements, fuel emissions, silent power, etc., as a benefit. It's not always going to be possible to save as much fuel as you want to meet the arrangements of silent power. Even in these times of fiscal tautness, it's relevant to look at all of these to make sure that you're getting a true opinion of what's going on the site.
Yeah. So there are variables to consider.
Yes, definitely.
Of course. Dan, Rob mentioned an 88% reduction in generator runtime. Is that a typical kind of result?
It all depends on the load, Brian. You need to sort of think about the battery, as Rob was saying when he opened up, about it's a box of energy, or you could think of it like a water tank. Yeah. So you can fill it up very quickly, but the tank by what would be a fireman's hose or a large generator, and then once it's full or the battery's charged, you can then turn the hose off or switch off the generator, and you then have your tank full of water or energy in this instance.
Yeah.
Then in terms of how you let that water back out or discharge the battery, you can either let it out very, very quickly in short bursts, or you could let it out slowly. And that would be the equivalent to the rate that the energy is being consumed. With a BES system, you can utilize the inverter to power large loads quickly. As I said, opening the big tap very quickly and then close it again without allowing a huge amount of water or energy to escape. However, if the site demand is a pretty constant load and you say open the tap on the water tank or put the battery system at 50% and leave it there for a long period of time, the tank's going to empty a lot quicker than allowing it to empty in very short bursts. And that's why getting the right application for a BES system is really important.
Okay. And what advice would you give to customers to ensure that they're getting the most from their battery or hybrid setup?
I think the main thing really is to understand how power is being used and energy is being consumed on site. Investigate how the overall load is made up. It's important to question electrical design calculations. I think a lot of electrical engineers are trained to specify power systems for grid connection, and therefore they follow the guidance which is suited to grid connected power systems, not necessarily temporary power systems. For instance, we've seen lots of projects that are requesting huge power supplies from a temporary system for instance, modular office buildings on construction sites. But really, if you think about how the power is going to be used within those offices, the electrical design might be based on each module within that office block requiring a 32 amp single phase power supply. And if there's around 50 modules, the electrical design might suggest that the peak load requirements around 530 amps per phase. As a result of this, a 300 to 500 kVA temporary power supply might well be requested. Within these offices, the newer electrical equipment is a lot more efficient and it's very, very low power consumption now. And the actual chance of each module within the office block getting anywhere close to consuming the full 32 amps that might have been allocated by the electrical design is never going to happen. Of course, all these sites are different, but it is important to understand these intricacies to be able to gain efficiencies through temporary power design on these sites. The great thing about utilizing BES systems for these instances is that you always have the peak power delivery available without having to have a large diesel engine running on site, just in case the load suddenly increases when you're not expecting it to. Think again about the tower crane or the scanner, as Rob was discussing. Concrete batching plants, large pumps that aren't running constantly are other examples of this. Battery systems as well can give you much greater insights into how and when your energy is being used due to the very accurate data logging and energy reporting that we can deliver through Greener's energy management software. It also enables the customer to gain much better insights into how energy is being used on site and to make the right informed decisions based on this data.
Rob, you're nodding. You're concurring with that.
Yes, definitely. I mean, it's just also to say that most best systems on sites will benefit from a turnkey solution.
Right.
So taking it off the shelf and plug and hope that some use is not going to be the way forward. You need to understand what the site load is and what's going on. It's also really important if you start using grid supplies to understand how these interact together. So grid generators, alternative energy sources such as solar and wind can all be used really well, but it's also need to be making sure you're understanding the regulatory considerations such as G99 protection alongside the grid and G100 for the import-export regulations. Just because it's there doesn't mean you can do it straight away.
Okay. Thanks for that. So at both of you then. So lots of information covered thus far. Clearly, there are several variables and considerations to factor, given the array of sectors and various applications that we're all involved with in the rental market. But if you could leave our listeners with one key takeaway, so as they're using their best units properly, as the title of today's webinar suggests, what would that be? I'll go to you, Rob.
Well, as Dan said earlier, the way that site loads are working nowadays is changing. Consultants are designing systems around full load currents and worst case scenarios. And as Dan said, it just doesn't happen anymore. The loads, the systems and everything are much, much lower. Buildings are being built much better, insulation. So I'd say the main thing to do is know your load. The crux of all energy use is what is the load going to be? Whether it's a BES, a grid or a generator supplied system, you still need to know what you're trying to supply. Knowing what needs to be achieved means it's possible to specify a solution for your needs, not just around what the rental fleet manager might have available at the time or what the sales manager wants to get out the door. Sum it up, I'd say using us with energy consultation, load studies, we can help you do that. You know your business, we know ours. So if you give us the challenge, we'll bring the energy.
I think Sam's smiling at that. Answering guys there. Dan, did you want to?
Yeah, I completely agree with Rob. I think knowing your load really is the most important thing when it comes to temporary power design. If you don't know exactly what you're powering and how it's made up, you can get it very wrong.
Yeah,
in that design process.
So come and talk to the experts.
Absolutely.
Okay, thanks for that. Now, as we've been talking, we've been receiving questions via the chat function, which Sam showed us earlier on. So I think now's a good time to have a look at some of those. We'll go through as many as we can. If we don't get through them all, I promise we will respond to you directly off air. So question number 1. Is there a limit to size and load? Who wants to take that one?
I can take that one, Brian. I think now that we have the ability to parallel batteries, there really is no limit. I mean, as I said earlier, we've ran some projects with up to 10, and there really is no limit on how many of these systems you could parallel together in an island or grid connected environment.
Right.
So no, really is the answer to that.
Technology's moved on.
The technology's there. I say when we have multiple batteries running in parallel, they effectively become one, as it would be a 500 kVA diesel engines running in sync is the same. The benefit really of looking at that principle and applying it to battery systems is you have all of that peak power available whenever you want it without having large engines running all the time.
Okay, that was a good question. So the next question I have is, where do stage 5 generators figure in all this? And Dan's just been, so I'm looking at you, Rob, and given that Power Electrics do have a sort of a fleet of stage 5 generators, and if any of our listeners do have a requirement, of course, for stage 5, please get in touch. Perhaps you could give us an answer to that one, please, Rob.
Sure, yeah. So, I mean, as Sam's just put up the image there as a prime example of stage 5 in the London area alongside batteries and tower cranes. The stage 5 engines, as a lot of us know, are needing to be run at set loads and high loads to keep the temperatures up for the emissions, etc., to be working. This is where the batteries really come into their own. So if you've got peak loads that are quite high and base loads that are very low, enabling the generator to run at its preferred level means that you need to take energy out of it. So the battery systems can do this. You can tell them what energy they can have. They will then work out by looking at the load how much they can take and how much needs to pass through, enabling the generator then itself to be running at what it thinks is its 60, 70, 80% accurate loads. So yeah, stage 5 really benefits from battery systems enabling, and we've worked very successfully with these around the London area, even from machines as small as 60 kVA stage 5s and batteries, enabling the heat cycles to be run through them and the emissions to be kept down low, and avoiding the faults of low loading on the generators.
Okay. The next question we have is interesting. There's been a few reports in the news of units catching fire. What are your views on that one?
I can take that one if you like, Brian. So I mean, yeah, there are reports. I mean, it's an area of concern. Of course, people talk about lithium ion as being volatile, etc. So the fleet of battery systems that we have at Greener, they're all manufactured in the EU, and they comply with the standards that you'd expect to come from the EU. The actual batteries themselves within our containers are BMW i3 electric vehicle batteries, so a very credible supplier there. So each container that we have or battery system that you've seen in the slides either has 8 or 10 of these batteries inside the steel container. So they really are safer than electric cars. The batteries are housed in the steel container, and also they're not traveling at 70 miles an hour, plus minus, whilst they're in operation. Also, the principle of design within these battery systems is all about prevention rather than cure regarding fire risks or the risk of thermal runaway. Any fire suppression system within a lithium-ion battery is likely to have a relatively limited effect once a thermal runaway event has occurred. So prevention really is the most important thing. So that the systems that we operate have protocols in place to firstly notify our operations desk of any parameters outside of where they should be operating. These parameters will be looking at inverter temperatures, individual battery cell temperatures, ambient container temperature, as well as electrical installation monitoring and smoke detection. All of this information is first presented to us as a warning at a low tolerance of what the PLC would be expecting, allowing our team to look into this and make adjustments to settings if required, allowing for the unit to continue to operate while the parameters are still in acceptable range. However, if these parameters do continue to further fall outside of the nominal range, an automated shutdown process is executed, preventing the risk of fire even further.
Excellent. Thanks for that, Dan. We've just had one pop in, which is, can the unit act as an uninterruptible power source during a generator failure or switchover? Rob, did you want to?
Yeah, so I'll take that one. The short answer is yes. It's not quite the same principle as a UPS, but the switching process of the inverters is such that it will act as it. And if you're running in a grid, and Dan might come back in if I've got this one wrong, but if it's acting as a grid shaving mode, then the 0.1, 0.2 of a millisecond switching time will enable it to basically act as a UPS. The advantage with this also as well is that you can use the energy store systems alongside a grid supply, and then have what we refer to as an active front end generator.
Right.
So if the grid supply was to fail, the battery takes the load, and then the front end generator can then start. And as Dan was saying earlier on, the bidirectional inverter charges means that as the stated charge starts to fall, should the grid supply not have returned in time, the generator can then start. Very similar to the systems that data centers and such use, is that the UPSs will come on and take the load, and then generators will spin up. But rather than having a spinning engine permanently there, the battery's taking the load until the actual engine is needed.
Excellent. Just looking at the marketing team now, I think that's the questions that we've had on listeners being waved at, as they say. So I think that concludes today's discussion. I'd like to thank our experts, Rob and Dan, for sharing their knowledge with us all today, and our marketing team for making it happen. And of course, a big thank you to you, our listeners, for joining us. I hope you found it interesting and that you got what you came for, importantly. There's a recording of today's webinar, which will be available on our website in the next few days. And of course, if you'd like to hear about up and coming webinars, then please subscribe to our email list and give us a follow on LinkedIn. And if you have any questions regarding this webinar or specific application you're considering, don't hesitate to get in touch with us. So thanks again, and we'll catch you next time.